Welcome back to part 2, Algebra students. We're going to be doing some factoring this morning and some putting back together of factors. We're going to start off with standard to factored form. You'll need to know how to do this. Basically, when you have a standard form of an equation, and our standard form, remember, is y equals ax squared plus bx plus c. That's the form that we're used to seeing, the one we started out the unit with. And factored form is y equals sum a times x minus p times x minus q, where p and q are our zeros. So we're going from one form to the other. I need to just factor this. I just factor it. I'm going to use the x factoring method. I want something that multiplies to give me negative 12, but adds together to give me positive 4. So I start by listing my factors. I have 1 and 12. 1 minus 12 would be negative 11. That's not going to get me there. How about 2 and 6? 2 and 6. You know what? A negative 2 and a positive 6 would give me a positive 4. And negative 2 times 6 is going to give me negative 12. So my factors are negative 2 and 6. Because my a is 1, remember, I can simply write this as y equals x minus 2 times x plus 6. And I'm done. That's it. Over here, I'm going to take a greatest common factor out. I can factor out a 3 and an x from each term. If I take a 3 and x out of 3x squared, all I'm left with is an x. And if I take a 3 and an x out of this 6 here, 6x, I'm just left with a 2, because 3x times 2 is 6. And that is my factored form of, that's my factored form here. And I would have very easily can find my solutions for that. Let's go to the next page. Factored to standard form. When I do this, I want to either FOIL, or remember we used to also do a box method where we'd put these on top and this guy on bottom, and we'd multiply these together, combine the middle terms. It's more common to do, and at this point you should probably go toward FOIL, because really that's just distributing everything from here into the second one. And we do that by going first times first, okay, outer times outer, that's my O, inside times inside, that's my I, and last times last, the last term in this set times the last term in this set. So let's just take that one at a time real quick, and I'm going to redraw it as I go. Remember, it's the FOIL method. It's really just distribution. So let's take first times first. X times x would be x squared. Now we need outside. Outside times outside. X times 4 is plus 4x. Now we need inside. The two inside terms. Negative 3 times x is negative 3x. And finally the last one here times the last one here. Negative 3 times 4 is negative 12. Now one thing you got to be sharp and catch is right here I can combine these two terms because they're like terms, and I come out with y equals x squared. A positive 4 and a negative 3 comes out to be just 1x, but I'm not going to write the 1 in front of it. I'm just going to leave it as x, and I end up with 12. So this is my final. This is my final answer, factored to standard. Over here, I can either multiply this set of parentheses times this set of parentheses and then multiply the two, or I could multiply the two into either set. You got to remember, multiplication is commutative, so it doesn't matter the order we go in. I'm going to go ahead and distribute again. Get rid of the parentheses first. So I'm going here, I'm doing first times first, and remember I'm going to have, let me go ahead and write my y equals 2 here, because I'm going to have to deal with that 2 in a minute. X times x is x squared. That's my first. Outer times outer. X times 2 is plus 2x. And then inside times inside. Negative 1 times x is negative 1x. I'm going to leave my 1 there for a minute because I got to deal with it again. And then last times last, negative 2, 1 times positive 2 is negative 2. That's my last. Now I have to combine these two terms in here. So when I come down to the next step, I get y equals 2 times x squared. Positive 2 minus 1 leaves me with just x. And then, of course, I have the negative 2 on the end. I have to now distribute my 2 into here. So 2 times x squared would give me 2x squared. 2 times x gives me 2x. And 2 times negative 2 gives me negative 4. And I am done with that. We're going to convert vertex to standard, remembering that vertex form is y equals sum a times x minus h squared plus k, where h and k are our vertex, is y equals a x squared plus bx plus c. To go from one form to the other, we first are going to rewrite this as y equals x minus 5 times x minus 5 minus 12. And we're going to once again use FOIL to distribute the x minus 5 into the x minus 5 and go from there. So I'm going to change pen colors. So FOIL, first, outer, inner, last, and then I'll save dealing with the negative 12 at the end. So first times first would be x squared. Outside times outside would be negative 5x. Inside times inside is another negative 5x. And last times last, negative 5 times negative 5 is positive 25. And then I can't forget my negative 12 on the outside here. Simplifying this, I get y equals x squared. Negative 5x and negative 5x is negative 10x plus 25 minus the 12. And for my final answer, I end up with y equals x squared minus 10x plus 25 minus 12 is 13. And there's my final answer. Over here, it's a little more complicated. Again, I'm going to have to FOIL, and I think I'm gonna go ahead and multiply. You have to go in order of operations, so it's exponents first, well, parentheses first, then exponents, then multiplication, then addition. So I'm going to try to write a little bit smaller over here, if I can. This is going to be y equals negative 3 times x plus 1 times x plus 1 plus 4. So the first thing I've got to do is take care of these parentheses inside. I'm going to do first times first, x times x, I'm going to have negative 3. X times x is x squared. That's my first. Outer times outer. 1x. Inner times inner. Plus another 1x. And last times last. 1 times 1 is 1. Plus 4. So now I have to distribute my 3 because multiplication is next in the order of operations. I have to distribute my 3 into here. So now I have to combine my like terms. I'm going to get y equals negative 3 times x squared plus 2x. 1x plus 1x is 2x plus 1 plus 4. Now I have to do multiplication next. So I have to distribute my negative 3 inside here. Let's do that. Y equals negative 3x squared, then to here, minus 6x, then in here, minus 3. All of that plus 4. Well, I can just drop my parentheses because when I'm adding, I simply add. It's like combining like terms. So at this point, my final answer is going to be y equals negative 3x squared minus 6x, and then my negative 3 and positive 4 results in a plus 1. And there's my answers. Finally, from standard to vertex form, we're going to find our vertex hk and keep the same a value. Well, my a value here is 1. So a equals 1 here. And to find my vertex form, I use negative b over 2a to get my vertex. So a equals 1, b equals 4, and c equals 3. We had to do this when we were using the quadratic formula. But this will give me my vertex. So I'm going to plug in these numbers to find my vertex. Negative 4 over 2 times 1 is going to give me negative 4 over 2, which equals negative 2. So vertex equals my x value is negative 2. But I don't know my y value yet. So I'm going to take the negative 2 and plug it in here in x and see what my y value would be. Y equals negative 2 squared plus 4 times negative 2 plus 3. Y equals negative 2 times negative 2 is a positive 4. 4 times negative 2 4 times negative 2 would be negative 8 plus 3. So y equals, when x equals negative 2, y equals 4 minus 8 is negative 4. Negative 4 plus 3 is negative 1. So that's a negative 1. This is my vertex. And now that I know my vertex and I know a, I can just write my vertex form. Remember, vertex form is y equals a times x minus h squared plus k, where h is your x value for your vertex and k is your y value. So I'm just plugging these in. This is my h, this is my k, and remember a equals 1, so I have y equals, there's no point in writing 1 times anything, x minus h, minus a negative 2 would be plus 2 squared minus 1. And that is going to be my final answer for this. My final answer is y equals x plus 2 squared minus 1. That's my vertex form. Scroll down a little bit. Might need a little extra room over here. We're going to do the same thing again here. We can see that our A equals 1, our B equals 6, and our C equals negative 5. We know that our y-intercept would be 0, negative 5, but that's not what we're about. We need to determine the vertex. So our vertex formula is negative b over 2a. So we take it and we plug that in. Negative 6 over 2 times 1 is just 2. So that equals negative 3. So our vertex is going to be at negative 3. We don't know the y value yet. To get the y value, we plug negative 3 in for each of the x values here. So I'm going to take this original equation and plug in negative 3. Y equals negative 3 squared plus 6 times negative 3 minus 5. So I'm asking myself, when x equals negative 3, what does y equal? That's what we're going to find out. Y equals negative 3 times negative 3 is positive 9. 6 times negative 3 is negative 18. And then we have our minus 5 on the end. Y equals 9 minus 18 is negative 9. Negative 9 minus 5 is negative 14. So I get a negative 14. From here I can just write out my vertex form, because remember, the vertex form is y equals sum a times x minus h squared plus k. We have it here and we have it here. Therefore, I'm going to rewrite it here. Y equals a times x minus h squared plus k, where h is the x value and k is the y value of my vertex. I just plug them in. Y equals, a was equal to 1, so I don't have to put 1 times this. I'll just leave it out. X minus my h value is negative 3 minus a negative 3 squared plus negative 14. So we can rewrite this as y equals x minus a negative is a positive, x plus 3 squared plus a negative, we can just simply write minus 14. And here's our final answer. And there you